Hi, good evening. Can you all hear me?
Yes, madam.
Good evening.
Good evening. So in this batch, total how many people? Anybody knows about that? How many people? Because only 3 people joined.
Actually, in a WhatsApp group, it's showing 12 participants. So maybe more than 8 people will be the group.
Okay, is this your first class or have you all attended the PMP section?
Yeah, PMT section we attended, but that will be the combined with all other people also,
All
like
other
electrical,
people.
mechanical,
Yeah.
like that, everyone together.
Right. Can anybody who has a mobile next to you, can you just text in that group saying about classes started? Because my mobile is charging, no charge, so it's not with me now.
Yeah, let
Okay,
me put
madam.
a message.
Yeah, please start. Text it. Meanwhile, we will start. Let them join. No problem. And these are the topics we are going to see. For overall chemical, no, apart from project management, there are 7 topics from chemical engineering: heat transfer, process calculation, thermodynamics, reaction kinetics, fluid mechanics, distillation, economic analysis. Today, the first chapter we are going to see, which is the heat transfer. You know, the heat transfer fundamentally it is done by fundamental type of heat transfer is 3 method. One is a conduction, convection, radiation. These are the very basic. Conduction, from one part of the body to another part of the same body, right? That's the heat transfer from one plate to next plate, or that's what called conduction. From one body to another body through physical contact, right? That's called conduction. Convection is through the within a fluid or within a gas, right? There will be a convection, transfer of heat will happen. It can be a natural convection or it can be your forced convection also. Natural convection means, if you have a hot water, it through air, it automatically cool it down. Right? That's a temperature difference and density difference will cause the heat transfer. The second thing is forced convection. Forced convection means through mechanical means, right? We force the air blow onto the either mechanical, blowing the air onto the particular surface or wherever the fluid or gas or something where the heat transfer should take place. Again, the temperature difference will make the heat transfer. Forced convection, motion is produced by mechanical means. The velocity is really low, it relates to the free. If the velocity is very low, then you can call in a free convection or natural convection. So radiation, it's not by from one body to another, no need to be in a contact or not even convection. It's something like in a race, right? Wave motion through a space or empty place. That's a radiation. What we are going to see, the conduction and convection only we are going to see. That's a rate of heat flow. That's called dq by d theta. Right? That's the rate of heat flow, which is equal to minus Ka dt by dx. K is your thermal conductivity. A is the area. This is the temperature difference, and dx is the distance traveled. dt by dx is the rate of change of temperature within the distance in the direction of flow of heat. A is the area. Right. Simple example, you can see there are 3 plate, right, which has the thickness, I can say x1, x2, or breadth, I can say x1, x2, x3. From the higher temperature to lower temperature, the heat transfer is taking place, right? So the distance travel is x. Temperature difference is for plate 1, I can say d2 minus t1, t2 minus t1, that's a delta t1. and this is x1 is the distance travel. K is the thermal conductivity of the material, the plate. Then area, right? That's the Q1, Q2, Q3. So if you say overall Q, which is nothing but sigma of overall delta T, that is nothing but T4 minus T1 divided by the resistance, right? Total resistance. Total resistance is nothing but R1 plus R2 plus R3. R1 plus R2, R3 is nothing but resistance, which is inversely proportional to conductance. That's what here you can see X divided by Ka. K is your thermal conductivity. This is the area. This is the distance travel. This is called overall Q. Normally, the unit of a Q is a joule per second or BTU per hour, or this is thermal conductivity unit, joule per meter second degree Kelvin. This is BTU, hour, feet, Fahrenheit. And this is the unit for heat transfer and thermal conductivity. So now we are going to see the convection. It's a majority of our chemical process is talking about the convection in industrial. So from one fluid to another fluid through a solid wall. Heat convection involves the energy carried by the fluid by the virtue of its velocity. So which is nothing but HA delta T. Delta T is the temperature difference, which is the surface temperature minus the air. Right? That's a delta T. H is your heat transfer coefficient, where in a conduction we talk about K, which is a thermal conductivity, but here is a H. So when a natural convection means solid surface is in contact with the fluid of different temperature from the surface, generally express dimensional relation. This is a natural convection. You need to remember all this number. I think we would have come across in our studies: Prandtl number, Nusselt number, Reynolds number, Kirchhoff number, right? And relay. See, a Prandtl number is nothing but Cp mu by K. K is your thermal conductivity. Cp is your specific heat at constant pressure. Mu is your viscosity. Right? Similar Nusselt number. H is your heat transfer coefficient. L or D is a distance travel. K is your thermal conductivity. Again here, mu is a viscosity. G is your kinetic viscosity, isn't it? G is a mass velocity, which is nothing. You can see all the abbreviations here. Capital V is the velocity meter per second. G is your mass velocity, which is nothing but kg per meter squared, which is nothing but V into rho. Right? This rho is also called kinetic viscosity, which is mu by rho. So this number, right, that you have to mug up. And the heat transfer coefficient for convection, especially the natural convection, this is the formula HL by K, which is equal to C into, there are a lot of derivation, but that is not the important for us. Here it is only a MCQ. So just remember the formula only. HL by K, which is the Nusselt number, C into Kirchhoff number, Prandtl number to the power of N, right? This is L cube rho GC, which is nothing but Kirchhoff number. Cp mu by K is a Prandtl number to the power of N. The C and N are constant, which has been derived by experiment basis. Then the C and N are constant. TF is your film temperature, which is nothing but surface temperature plus your air temperature divided by 2. This is for natural convection to calculate your heat transfer. If I know H, that's the heat transfer coefficient, then I can substitute in this delta T, A and H. You can calculate from this formula. You can calculate and you can substitute here. Then you can calculate the rate of heat transfer for convection. This is for natural convection. And simply they're talking about if it is a natural convection, if it is for air and a flat plate, right, then the simple formula for heat transfer coefficient C into delta T by L to the power of N. The C and N are constant. Delta T is a temperature difference, which is nothing but surface temperature minus C air temperature. L is the distance travel. So they have derived for simple natural convection and flat plate. So they see the question, if they're talking about the natural convection flat plate, you can calculate H from this formula. How it is being derived? It's a lot of substitution there. You can show it is derived H equal to C into delta T divided by L to the power of N. You can prove them, but that is not important for us. We only need to remember to answer MCQ question. H equal to C into delta T divided by L to the power of N. Then the overall heat transfer coefficient, which is U, is the overall heat transfer coefficient, equal to 1 by Hi plus xw by k plus 1 by h naught. I is your, I can say, inside surface, right? From inside to the surface. This is in the plate, right? Or in the thickness of the wall. Xw is the wall thickness and k is the thermal conductivity. This is the outer, right? Outer surface, I can say, 1 by h naught. So that's the overall heat transfer coefficient. Represent the total resistance to heat transfer from one fluid to the other fluid. It is a measure of overall ability of series of conductive and convective heat transfer to transfer the heat. Always remember, R is a reversely proportional reciprocal of thermal conductivity. This is the overall heat transfer. If there is a scale deposit, right, in the pipe or in the plate, if there is a scale deposit, then you have to take into consideration of 1 by Hd. This is a heat transfer coefficient of the deposit. That is all same. So then overall heat transfer coefficient, same way, Q equal to UA delta T, where we saw there natural convection HA delta T. If you say overall heat transfer coefficient, it is a UA delta T. You calculate overall heat transfer coefficient through this formula, then substitute here. Q by A is called a heat flux. There are different unit conversion it is given. One more thing I noticed in, I got a feedback from the previous students. They are telling about a different unit they have been asking. So you need to mug up some of the basic unit conversion. They are not giving the unit conversion. Next is the forced conversion. If it is a natural conversion, we saw the C equal to Nusselt number equal to Kirchhoff number, C into Kirchhoff number, Prandtl number to the power of N, which is nothing but HL by K. From there you can calculate H. This is for natural convection. If it is a forced conversion, first thing, the same formula, Q equal to HA delta T. Here heat transfer coefficient, area, this is the temperature different, all are same, except the H you need to calculate based on the, this is the formula, right? They're talking about C into Reynolds number to the power of N, Prandtl number to the power of N. Whereas there it's only Reynolds number, there is a Kirchhoff number and Prandtl number to the power of N. That's the overall one. You can see here. Kirchhoff number, Prandtl number to the power of N. This is for natural convection. If it is a forced conversion, the formula is Reynolds number to the power of N and Prandtl number to the power of N, HL by K. These are the constant, right? So that should be given from a different formula, or the value will be given. So for that, they have derived and calculated, if it is a laminar flow, please mug up this one. Laminar flow CMN value, right? C value is 0.664, M is 1 by 2 and N is 1 by 3. Right? And if it is a turbulent, C is 0.037, Reynolds is 4 by 3, I mean M is 4 by 3 and N is 1 by 3. And this is a turbulent. How do you know laminar flow or turbulent flow? So then you have to calculate the Reynolds number, right? Reynolds number, laminar flow. If it is in between more than 5 into 10 power minus 5, then it is a turbulent flow. So first, by giving a Reynolds number, how to calculate? You can see the formula, right? Here Reynolds number is, right, dg by mu, right? D is your diameter, G is your mass velocity, which is a V rho, or we know V is the velocity, rho is the kinetic viscosity, right? Kinetic viscosity, correct. So you can calculate the Reynolds number. If it is less than 5 into 10 to the power of 5, then it is a laminar flow. If it is greater than 5 into 10 to the power of 5, then it is a turbulent flow. Then if it is a laminar flow, you can use this formula, right, to